In this demo, we will learn how to optimize the runtime performance of regular expressions through compilation, and we will cover some of the security considerations when applying regex. When defining regular expressions, especially when the pattern is quite long, I like to extract the pattern and store it into a string constant. I'll copy the pattern and define a string constant named customer data pattern, which we can assign using the copied pattern. After completing this, you may notice one usability annoyance. The colorized highlighting of the pattern elements no longer occurs because Visual Studio has no way to know that this string represents a regex pattern. It could be easily inferred when it was used as an argument to the matches method. But all is not lost. There is a handy trick we can use to give the IDE a hint about this string. If we include a comment immediately above which specifies the language equals regex, then the IDE can use this to restore the highlighting. Much better. We can now update the method call to use the constant field. If we include a comma, we can explore another overload revealed by the IntelliSense. It's possible to provide some regex options after the pattern. Regex options is a flags enum we can use to provide one or more options to control regex processing and matching. For now, we'll specify regexoptions.none. If we continue to add another argument, the next overload is revealed, which accepts a timeout. Why would we want to provide a timeout? Generally, regex should perform reasonably quickly for most comparisons. However, because of various characteristics such as support for backtracking, it's possible to write patterns which take exponentially longer even on relatively short input strings. A malicious user could find ways to provide input to regular expressions which could cause a denial of service attack. Therefore, we should take some steps when using regex. If we control the input strings and the regex pattern, then for the most part, we can avoid problems by thoroughly testing the regex against various examples of potential input strings. When we have unconstrained input strings provided by users, or when we accept a pattern from a user, which we then attempt to use for matching, we need to take more care. Any untrusted input to applications is a potential security threat. We can mitigate most issues by providing a timeout for the regular expression. The timeout defines the approximate maximum time for the regex to execute a matching operation. Adding a timeout to all use of regex is a sensible idea. It avoids unexpected input or pattern behavior from impacting the regular operation of the application. It's most crucial when processing untrusted data or accepting a user-provided pattern. Adding a timeout can prevent attacks and accidental misuse, causing a match to run for a very long time and to hog resources. For our simple match, 1 second should be plenty of time for the matches to complete. Setting a timeout here ensures that if we were to read in an unexpectedly long row, we would prevent matching from exceeding our time limit. There is something else we can consider when applying regex in our code. By default, regular expressions are interpreted at runtime. The regular expression engine converts the expression to a set of internal operation codes when regular expressions are instantiated. When the engine executes a regular expression, it interprets those internal codes. When using the static regex methods, the same steps must take place, but the static methods offer an advantage in that a cache can be used to avoid repeated overhead from reparsing the same pattern time and time again. Interpreted regular expressions reduce the startup time at the cost of slower execution time. Regular expressions may also be compiled directly into MSIL, the Microsoft Intermediate Language, at startup. Compiling expressions incurs a slightly higher startup cost, but it reduces the runtime cost of executing each match. Microsoft recommends using interpreted regex for infrequently used regular expressions. Compiling should then be considered when an expression will be reused against many different input strings. In such situations, we should ensure we reuse the same compiled regex instance. To compile and reuse our regex, we'll define and assign a static read-only field. We'll name this field customer regex. To assign its value, we will create a regex instance. The regex constructor accepts similar arguments to the static matches method, only without the input string. We pass in our customer data pattern as the first argument, and next we can supply the regex options. This time, we need to provide an option to specify that we want this instance of the regex class to be compiled into MSIL. Finally, we will include our 1 second timeout. Using a static field here ensures that we will reuse the same instance of our compiled regex across all instances of the customer data processor. We can update our method to use the compiled regex instance. We call it matches method and pass our row as the input string. This is the only argument we require because our compiled instance is already configured with our pattern, options and timeout. This completes our changes to optimize the regex usage in this code. We can explore and run some benchmarks to prove the potential benefit of compilation. In the benchmarks project, I've included a compiled regex benchmarks class. This class has a sample row of data. It also has a field to hold a regex instance. Assigning this statically is important as we are not measuring the compilation cost in this benchmark. We expect the compilation cost to be a one-time occurrence, so its impact is relatively small. There are 2 benchmarks in this class. The first measures the performance of using the static regex.matches method as we were doing not so long ago. The second measures the performance of using the compiled regex instance, just as our updated code now does. We need to configure the run method in the program file to execute benchmarks from the compiled regex benchmarks class. As before, we must also ensure that we set the build to use release mode and change the startup target. We can then run the benchmarks without attaching the debugger. I'll speed up this portion of the video to get to the all-important results. Upon completion, we can compare compiled versus non-compiled in the summary. The compiled regex executed approximately twice as fast. Both benchmarks allocate the same 88 bytes. For infrequently used regex, the benefits of faster execution may be outweighed by the one-time cost of compiling the regex in the first place. However, once we begin processing larger data files with tens of thousands of rows per file in this application, then this performance boost will provide a more significant impact. Before moving on, I'll close the console and ensure that I return to debug builds and reset the target to the data processor console application. We can close these files in the editor as well.